Module 5, Lesson 2. In this lesson we are going to continue with the previous script and add the accuracy assessment. For this purpose we are going to split our sample feature collection into two parts. A training set to train the classifier and a test set to do the validation. In order to split, we have to create a property, a column with random numbers. So we are going to use the feature collection GCPs, and then there is a function to create that random column, and that will add a column with pseudo-random numbers between 0 and 1. Now we can split the dataset based on that random column, and normally we use 70% for training and 30% for validation. Here we have a very low number in this hypothetical case of samples, and we're going to use 60% of the points for training and 40 for validation. So I'm going to filter the feature collection based on the random column for the training GCPs, and there I choose that the random column needs to be less than, LT is less than 0.6. And we do the same for the validation. Give it another name, validation GCPs. And there that should be the remainder, so that is greater than or equal than 0.6. Now, as we did in exercise 1, we are going to use the training GCPs to sample the values from the bands and to create the spectral signatures for the classes. That's similar. So we use again the sample regions function and build the dictionary, where we use the collection, that's our feature collection, but then just the training GCPs. And we'll use the land cover property, use a 10 meter pixel size, and in order to speed up the classification a bit, we use a tile scale of 16 that will just retile the existing tiles. So scale 1 is just the original tiles. Now the calculation will be applied on tiles that are scaled to 16. We can train now the classifier, so similar as we did before. And we use the random forest classifier with the value of 50 like we did before. Create a dictionary for the classifier. And we'll use for the features the training dataset, and for the class property that's land cover. The input properties is our composite layer, and then with the band names. And now we can classify the image as we did before, but now we just use a smaller dataset. So that's composite.classify and then the classifier that we defined. And now we want to visualize the result, so I'll just save the script, because I'm going to copy that part from the previous script. So it's always good to reuse snippets of code that are already okay, so you don't have to reinvent the wheel. Paste it here. Show some errors there, and that's because we missed a comma. Let's run. And we see here there's another error because I used the wrong random forest classifier, and that one has been replaced with the smile one, the one that we previously used. So if I change it to smile and I run it again, it will run now without errors. Now we can proceed with the accuracy assessment. So create a new variable that's called test, and that will also use sample regions to use our test points to sample from the classified layer. So similar as with the training areas, we build the dictionary, and the feature collection that we use is validation GCPs that we created before. For properties again, land cover. Also here scale of 10 meters and a similar tile scale as we used for the training. So far the code is similar to training, because we just need to sample the values. And now we can create the confusion matrix, called test confusion matrix. And there is a function error matrix. You can look it up in the docs. And that needs the actual values, so from our sample, the predicted values, so from the classified image. And that will return a confusion matrix. Our length cover property of test is the input, and classification is the predicted value. Now we can print the results, and this can cause an error, sometimes a timeout. So you could also export this to a CSV file. Let's print a confusion matrix, put a little string there, and then the test confusion matrix variable, which contains the matrix. Just copy it. And we can also print the accuracy of the classification. And we use there the test confusion matrix, and then we can apply an accuracy function to that, which will give us the overall accuracy. It can also calculate other accuracies, like the consumers and producers accuracy, or the kappa statistic if you want that. So you can try that. I run the script, and it's all parallel process, so while it's still visualizing the classification result, we can see the matrix and the accuracy. Now for the assignment, do the same for your own study area and submit the link to the code. Good luck!